5. Writing equations of parallel and perpendicular lines. This is a set of parallel lines. Parallel lines have the same slope, right? So, the slope of this, rise 3, run 1. Slope of this, rise 3, run 1. Both of these have a slope of 3. So, parallel lines. Two non-vertical lines in a plane are parallel if and only if their slopes are equal and they have no points in common. Vertical lines are always parallel. That exception in there is because we can't say that vertical lines have the same slope because their slopes are undefined. So parallel lines have the same slope and no points in common. Coinciding lines are the same line. They have the same slope and all the same points. And intersecting lines have different slopes and 1 point in common. So, are the following pairs of lines parallel? One way that we can tell one way that we can tell would be to put these in slope-intercept form and compare the slopes. Another way, so if I multiply this entire equation here by 3, 3x minus 4y equals 12, and I multiply that and I get 9x minus 12y equals 36. If I solve these two equations for y, I'm going to get that y equals 9 over 12x, or 3/4 x, plus some constant here. So, because this half of the equation is the same, and these two parts are different, then yes, these are parallel. If that doesn't make sense to you, put them in slope-intercept form to double check, right? So 3x minus 4y equals 12, minus 3x from both sides, negative 4y equals negative 3x plus 12, divide by negative 4, y equals 3/4 x minus 3. And if we do the same to this one, we minus 9x from both sides. We divide by negative 12. We're going to get that y equals 3/4 x plus 6. 3/4 x. What I meant to write. Alright, so same slope, they are parallel. If we do the same trick for b, where we multiply this equation by 3, we're going to get 15x plus 12y equals 36, which is the same as the line we have here. So these two lines are the same. They are not parallel. They are coinciding. They're coinciding. They're the same line. And again, if we put these in slope-intercept form, minus 5x from both sides, divided by 4, and then we do the same thing here. Divide by 12, divide by 12, divide by 12. Once again, going to be negative 5/4 x plus 3. So, same line. Not parallel because they're the same line. They're coinciding. Have you ever made a purchase over the internet? This is how you can tell that this textbook is older than you are. Electronic commerce, or e-commerce, has changed the way Americans do business. In recent years, hundreds of companies that have no stores outside of the internet have opened. Suppose you own shares in two internet stocks, Bookseller.com and WebFinder. One day, these stocks open at $94.50 and $133.60 per share, respectively. The closing prices that day were $103.95 and $146.96, respectively. If your shares in these companies were valued at $5,347.30 at the beginning of the day, is it possible that the shares were worth $5,882.03 at closing? So the total amount of money that you have, right, at the beginning of the day, you have $5,347.30, and that is equal to some B shares of Bookseller, which is $94.50 per share, plus some W shares of WebFinder that are $133.60 per share. Now, the closing prices for those were $103.95 for Bookseller and $146.96 for WebFinder. And we want to know if it is possible that the shares were worth $5,882.03 at closing. So, if Bookfinder is our X, right? I'm using B here so I remember what these are, but Bookfinder is our X, and Bookseller is our X, and WebFinder is our Y. If we were to solve for W, we would get the slopes and the y-intercepts of these two lines. And I think that is going to be the easiest way to demonstrate this, what's going on here. So if we want to solve each of these for one of these variables, honestly, it doesn't matter which variable we solve for. We could make Bookseller be the y and WebFinder be the x. It doesn't matter. Let's just say we're going to solve for W, right? So 5,347.30 minus 94.50 B equals 133.60 W. And then we have to divide everything by 133.60. And so we have 5,347.30 divided by 133.60. Which is 40.02 approximately. And 94.50. This is a slope of 0.707. So that's the first equation, right, for the opening. What about the closing? If we solve this one for W, 5,882.03 minus 103.95B equals 146.96 W. We're going to divide everything by 146.96. And that gives us, again, an intercept of 40.02. And a slope of 0.707. So, yes, it is possible that the shares were worth 5,882.03 at closing because these are the same line. The line, the set of shares, pair sets of Bookseller and Webfinder, that would give us this total at these two prices at closing is the same set of numbers that would give us this total at these two prices at opening. So yes, when we put this in slope-intercept form, we see that these are, in fact, the same line, meaning, yes, it's possible that the same number of shares could give us this total at opening and this total at closing. Write the equation of the line that passes through the point for -7 and is parallel to the graph of 2x minus 5y plus 8 equals 0. So, in order to write the equation of a line, we need a point and we need the slope. If it's parallel to 2x minus 5y plus 8 equals 0, it's going to have the same slope as this line. So, what we would need to do is we need to first find the slope of this line. So, I'm going to move 2x over, and I'm going to move 8 over. Get negative 5y equals negative 2x minus 8, and divide everything by negative 5, and that's going to be y equals 2/5 x plus 8/5. So the slope of this original line is 2/5. Now, if I want an equation to put it in point slope form, y minus y1 is negative 7. Equals the slope of 2/5, x minus x1 is 4. So we could leave it as y plus 7 equals 2/5 x minus 4, or we could put this in slope-intercept form by distributing the 2/5, that's 8/5, and then subtracting 7. Now, in order to do negative 8/5 minus 7, we're going to have to turn that 7, we're going to have to get a common denominator, which means in this case is going to be 5. So multiply by 5 over 5, which would be 35 over 5. And that would be 43 over 5. So you can leave it like this, or it would be better actually to cancel out that double negative. I did the same thing again. I'm smart. So you could leave it like this. Just turn the minus negative 7 into a plus 7. Or you could put it in slope-intercept form. What do you notice about the slopes of these two perpendicular lines? So if we pick 2 points here and we find the slope of this blue line, it is a rise of 3 and a run of 2. So that's a slope of 3/2. And if we pick 2 points on the red line, it's a rise of 2 and a run of -3. So it's a slope of -2/3. So perpendicular lines have slopes that are opposite reciprocals. Opposite meaning one positive and one negative. Reciprocals meaning that you flip the numerator and the denominator. So 2/3 and 3/2 are reciprocals. Two non-vertical lines in a plane are perpendicular if and only if their slopes are opposite reciprocals. A horizontal and a vertical line are always perpendicular. Write the equation of the line that passes through the point at -6, -1 and is perpendicular to the graph of 4x plus 3y minus 7 equals 0. So again, we need to put this in slope-intercept form so that we can get the slope. So minus 4x, add 7, 3y equals -4x plus 7, divide everything by 3. We're going to get that y equals -4/3 x plus 7/3. That's my slope. If I want a line that's perpendicular to that, my slope of my new line is going to be a positive 3/4. So, since this line is negative, I make my new line have a positive slope. That's the opposite part. And then I switch the 4/3 to be 3/4. That's the reciprocal part. And then we can use our equation, point slope form. To give us the equation of the line. And more properly, this should be y plus 1 equals 3/4 x plus 6, because when we subtract a negative, we get a positive. And then we could put it into slope-intercept form if we wanted. All right, so that is equations of parallel and perpendicular lines. Again, hopefully this stuff should all be review for y'all. But we will talk about it more this week.